It's quite hard to go after such an interesting subject, but I still will be presenting you Open Ocean and what we are doing. My name is Renaud Laborbe, and I'm the founder and the CTO of Open Ocean. So what I will tell you is I will briefly present you Open Ocean, and we are building a software called Metocean Analytics, and this software is using the CMEMS Ocean Metocean data. So I will show you how we can have a Metocean study into our software based on the CMEMS data. So few words about the company. We have been created in 2011. We are based in Paris, Brest, and South America. We are a team of oceanographers. I'm also an oceanographer. And we gather also a computer scientist and engineer. And we are working on numerical simulation, on parallel computing, on spatial data mining and analyze. And we put a lot of effort on the web technologies. But we are not only working on the web, we are also involved in an R&D project, and we recently gained fundings on PIAV. I think there is a talk about these French fundings, and we are for this collaboration, for this R&D program, working with CLS, and we will use their expertise in analyzing SAR images data, satellite data, in order to get better atlas of wind and wave atlas, wind and wave ocean atlas. So we have also partners for R&D, so in this case CLS, but also France Énergie Marine. But we also are working with business partners such as Ocean Pixel in Indonesia and Aquaterra in the UK. We target three kinds of markets, offshore winds, but also wave and tidal. We started the company on the wave and tidal market. And we are now working also with the oil and gas industry, and you have a few references for each market on this slide. So with all this expertise and all this background and this knowledge, we realize that on one side, you have people like a lot of modelers that are gathering a lot of data, and they are working very hard to produce the base data with the base schemes of assimilation and doing a lot of complicated things that we have seen all those days. And on the other hand, you have people that have offshore projects, and they have a hard time to find data and analyzing those data and make sure those data fit the need of their project, of their offshore project. In both industry I've been mentioning, offshore wind, wave and tidal, and even the oil and gas industry. So with this in mind, we wanted to bring easier access to those data and these analyses. So this is why we built the Metocean Analytics. It is a web platform which has three functionality. First one, unique worldwide catalog of different sources of data where you can query the data that fits your need. And then you have a bench toolbox that you can, like a lot of tools that helps you analyzing those data and visualizing those data. And you can also share those data with your collaborators inside the platform and generate your own PDF report with the information you want for you to split those information with whoever you want. So I'm a bit confused, but that's okay. I will show you a live demonstration. So it is not in the Black Sea like it's written, but I will go online and show you how our interface works. So I'm online right now, so it's an easy URL. You plug your login and password. And Now you arrive on the home page where it gathers all the projects. I'm connected with my own login password right now, so it gathers all the projects I've been working on. And here I will like to show you a project in the Baltic Sea. So it's not as easy as it's supposed to be to see because of I don't know why the resolution of the screen is not ideal here. But still, you arrive on a map, so I'll make it as clear as possible. You arrive on a map in the Baltic Sea. You can zoom in and zoom out. And you can have few information on how the currents condition and how the metocean condition looks like. You can go on this panel and you see that you have wind, wave, currents, maps. So let's start with currents because this current is based, those data are based on the Swedish Institute of Meteorology, and I get access to those data with the CMEMS portal that I've downloaded. And I have selected the mean current surface magnitude. So if I look, zoom a little bit, I can see that you have few area where you have a stronger current. So let's make the exercise of looking at those points and see if it's worth, I don't know, building a tidal park project, just to give an example. So in this interface, you have three main parts: the query, the analyze, and the report, as I said. So you go to the query, and you can choose any point of interest just by clicking on the map, and a pop-up will appear, and you can select the point of interest. Here, I already computed 2 points, one here and one there. And I have computed a point where you have a stronger current to see if it's a good idea to have a tidal farm over there. So now that I have computed those statistics, I can go in the analyze part, and I will look at the current field, and I can get a rows distribution and look at the rows, and this statistic will appear on your screen. I was not on the right point, as you've seen. I chose 2 points, so I'm sorry about that. So I was surprised of the result. So at this area, the current looks more like this, and it's much better. So you say, oh, it seems like you have a tidal effect, and it can be very suitable for a wind park. So let's go and keep going, digging information at this specific area. So let's see how the distribution looks like of the current speed. So you look at the distribution. You say, okay, why not? So on the x-axis you have the current magnitude, and on the y you have the occurrences of the current magnitude, and you can play with the mouse and see that so I selected from 0 to 1 meter per second the range, and so you can see that 76% of the time the current is less than 1 meter per second. And so it already gives you that it's not a good place because the current magnitude is very low in this area. So my point is, here in few minutes, with a little bit with very good data and a little bit of analysis and a web interface, you can have very interesting analysis just on the web. All the data, you can access all the analysis. You can, download as an image, Excel, MATLAB, or NetCDF. So if you are a scientist and you want to work with those data, it's just a question of seconds, and you download the data files of your interest. I have another map that can be interesting in the bathymetry. I'm using here the EMODNet sources. It's another European source with a very good quality. And it also tells you that it's not very deep in this area, less than 20 meters. So definitely don't build a tidal farm over there. It's not deep enough. But the Baltic Sea is known, so I'll zoom out a little bit more. is known, I will remove this bathymetry, sorry. The Baltic Sea is also known for their wind farm. So here I know there is a wind farm called, forgot the name, give me 1 second. Energy B Baltic 2. I know there is a wind farm at this location, and we also have a wind data into our software, so I can perform the same kind of analysis. So let's have a look to the mean vertical profile of the wind speed. And I know that normally a wind turbine is at 100 meters above the water. So I'll go on this profile and I select with my mouse 100 meter, and I can see that the wind is more than almost in average 9 meters per second, which is suitable for wind turbine. I have also many statistics that can have access, like the wind rose, and I can select the depth, the height. So 100 meters is a good height. And you can play along with many different statistics depending on your need. What else would I show you? You can analyze waves data, are very useful also, and wave data can be used to do the dimensioning of your foundation or your infrastructure. So I go to extreme value because this is what will help you to dimension your foundation. And here I have the return per use, the maximum wave that you are expecting to have in the next 100 years is 3.17 meter. So it's definitely suitable. It's very small. So it's very good to have a foundation. It's very easy to have a foundation over there. And as we are very transparent, we put all the fit and all the statistics that we have been computed, all the laws that have been used, and what the theory what the theory we have been used to compute those data. Everything is available into our software, and so it's very transparent. So this can fit the need of our offshore client for the dimensioning. And there is another phase which is interesting, is will it cost a lot of money to go and have operation over there that will require a boat. So in this case, I can go to metocean. It's when you want to cross two different fields, like field from wind and wave. And I would like to estimate if it will be easy to do different maintenance operation. So I know my operation offshore will depend on wave height and wind speed. So I select these variables. And here I can define the constraint of my operation and see how many days in average I will have to wait before I can use my boat and do my operation. Let's do an example. So let's say I have a 6-hour operation, and it's to install a pipe, for instance. So I don't want my boat to have a lot of waves. So let's select the wave less than 1 meter height, and wind. It can have a little bit of wind. Let's say 15 meters per second wind. And for each month of the year, I know that in average, I will have less than 1 day, here is 1 day, to wait before those constraints will be met. Anyway. And I have the variability also with this gray line. Okay. Do I have more time? So at what time do I need to finish? Okay. So you go to the report section and you can generate a report with all those, generate a PDF report with all the statistics you can download. And we have many areas of the world. So I'll go back here to all my projects. I will show you just another area. It's not based on the CMEMS data, CMEMS data, but I like it because I can go to the data validation section, and here we will show for the Gulf of Mexico, all the buoys that are available, I like to choose this area because there are a lot of buoys. And for each of those buoys, we have performed comparison, a score of the quality of the model versus the buoy. So let's check, for instance, for the wave. I'll pick up any wave. So here, I will remove this. You have a bias and a correlation that are available for this wave for 3 different variables, and I can have a more go deeply into this analyze, and I will go straight to this table. I have many scores that are available, and I can even have the regression between the model versus the buoy to give you a real knowledge on how good is the numerical simulation. And we perform this systematically with all the buoys and all the numerical simulation that enter into our catalog. So we are very transparent on the quality of the data. Another nice functionality for our client is the possibility to invite people. So you go to your account, to your profile, and you can invite, so that's my account, and I can just enter an email here, and I can invite people to share the same info. I just enter his email and press send. He will receive an invitation, and he will be able to connect to the same data, the same analysis, to the same discussion, and take decision based on the same data, which can be very interesting also. Everything is described, all the area available. If you go to the analyze, all the statistics are described. If you go to this question mark, you have a very precise description on all the laws that it's a class on extreme event analysis. So everything is very well documented here. So I forgot to show you something. I will go back to my Baltic Sea project right here. And if I go to the data validation section, and here for the current, I see that all the information where we get those data based on the high rhomb. I don't know how to pronounce this numerical simulation on the Swedish Institute of Meteorology. Everything is very well documented, and all the references are here. And we also can refer to the validation documentation that you get on the Marine Copernicus Service site. So we use the work that have been done into our software. So I think I did a good overview, and I will come back to my presentation. So we wanted to have a product that fits the need of our clients. So it fits the need for the feasibility phase. Should I go there or not? Is it worth going into a new area or not? But you can also, with our tool, with very easily in 5 minutes, get a good knowledge on how much money you will have to plan your operation. Will it cost you a lot, or will it be easy to plan the operation in this area? And we can also meet the detailed design and feed front-end engineering design needs through these tools with the extreme analysis. So as a conclusion, I think it's a great added value based on all the work that has been done in such meteorological institutes such as MyOcean and MetOffice and everything that has been gathered into the CMEMS services. We are using several data sources. We use a lot, of course, the CMEMS data. But not only, EdModNet aussi is also a great European initiative. We can also take the catalog of our client for a private catalog. Only the account of my client can go and access the data. So you can choose either it's a public catalog and everyone that is using this software will have access, or just on the private catalog. And this tool is quite new. We are always improving it. So, and there were a great opportunity to try different things with a uptake tender. So we applied for this thing, and we proposed the MetOcean Data Advisor. So it's the possibility of people of a community to score, to give, is this data set good for my need? Like you were saying, maybe the global data set is not very good for SWOT analysis. So you will be able to say a good score, a little bit like TripAdvisor will say, give a good score if you have a nice vacation in a hotel. Like you will be able to score the data set depending on the use of this data set. Because I've heard a lot this morning what is good and bad, and there is also something that I think it's important, is good for what and bad for what. And global data set is very good for many things, and regional data set can be bad for something and good for another. So it's important to see which phase of your project and what kind of project. Is it tidal, is it SWOT, is it oil and gas? So this is what we think there is a need to qualify the data set. And one thing, we have a great tool to analyzing data, but it's nothing without data. So we need more data, and please, if you need something to valorize those data, if you think that maybe all the work you are doing in your laboratory or in your institute can be valorized through such a tool for internet use or to spread the word, we are looking to make partnership and anything we can think about to make a bigger catalog and be the people at the sea to be able to use those data. And today, not to save the ocean from the plastic, but at least to have a well-designed infrastructure and better planification of their operations. And it's already quite important. So feel free to get back to me if you have such a data. Thank you.